Previously, we have talked about conic sections, introduced them, and started with the first conic section, which is the circle. So now we're going to go to the other conic sections, which has a different treatment than the circle. And we're going to start off with a parabola. So, we define a parabola as the locus of points P in a plane that is equidistant from a fixed point F called the focus and a fixed line D called the directrix. As a result, a parabola is the locus of points P for which the distance between FP should be equal to the distance of PD. So let's say this red curve here is our locus of points. As you can see, as the points go along, this distance from the point to the fixed point called focus should always be equal to the distance from the fixed line called the directrix. So that these two distances should always be the same. So that what we will form is the conic section parabola. Note that in the general form, ax squared plus cy squared plus dx plus ey plus f equals 0, this equation will represent a parabola if either a is equal to 0, like this, or c is equal to 0, like this. If c is equal to 0, then the equation form is actually representing a quadratic function. Otherwise, it just represents the usual parabola. But we're not going to focus on it being a quadratic function. We're going to focus on the parabola itself. Now, if vertex V is located at 0, 0 here, then the focus F is either on the x-axis or on the y-axis. So for us to be able to get one of the simplest equations for our parabola, let's place our F here on the x-axis with the coordinates a0. And let a be the distance from the focus to the vertex. That's why we have a coordinate a0. Now, by the definition of a parabola, since the vertex is also on the parabola, we can then also say that this distance from the vertex to the focus will also be equal from the vertex to the directrix. Hence, this point here is actually the point negative a, 0. Thus, this is the reason why the equation of the directrix is x is equal to negative a. So this distance is a and this distance is also a. Now, that being said, we can now compute or we can now show the distance between endpoint P to this line, since we already know the equation of the directrix, and the distance of the point, since we now know the coordinates of the focus. So, let's move there you go. So, again, we have defined that the distance between point P and the line D should be equal to the distance between point P and point F. So, as we can see here, this distance from point P to this line, since the line is vertical, would always be that's a horizontal distance. So wherever we place like this, it's also a horizontal distance. So therefore, to get the horizontal distance, as we have mentioned before, we can subtract the abscissas instead. So therefore, this distance here, the distance between this point and this line, would be the absolute value of x minus negative a. Absolute value because we're getting distance, not the directed distance. And if we get the distance from a vertical line, we subtract the abscissa of the point to the a value, to the value shown in the equation of the vertical line. That's why we have x minus negative a. And this is equal to the distance between this point and this point here. So since that is an oblique line, we need to use the distance formula. So therefore, we're going to have the square root of x minus a squared plus y minus 0 squared, using the distance formula between the coordinates of p, xy, and f, a, 0. Simplifying, we're going to have x minus negative a becomes x plus a is equal to the square root of x minus a squared plus y squared. So therefore, to remove the square root, since in the general form a while ago, we don't have a square root, we take the square of both sides. So therefore, this becomes the square of x plus a is equal to, this gets cancelled, we're going to get x minus a squared plus y squared. Expanding the two square of binomials, we're going to get x squared plus 2ax plus a squared is equal to x squared minus 2ax plus b squared plus y squared. Simplifying things, x squared gets cancelled. They are on the same side. And if I move this here, I'm going to get that's 2ax plus 2ax is equal to y squared. By using the symmetric property of equality and combining like terms here, I'm going to get y squared is equal to 4ax. And this is now actually one of the standard forms of the equation of the parabola, with the condition that its vertex is at 0, 0, and at the same time it opens horizontally. So there you go. Which would mean that there is not just one standard form. Unlike in circle, where you only have the center radius form as the standard form, here we would have different standard forms. And this depends on the following. Let's put this here. So our standard forms, standard forms would depend on the orientation of your parabola, whether it opens either horizontally or it opens vertically, and where the vertex is. Is it at 0, 0, or is it at another point hk? What we have derived here is the parabola opens horizontally and the vertex is at 0, 0. So we have y squared is equal to 4ax. If the parabola opens vertically with vertex at 0, 0, this becomes x squared is equal to 4ay. The derivation will just be the same. Once we have hk, this now becomes y minus k squared is equal to 4a times x minus h. Just like how it appears in the equation of a circle. And similarly, if this vertex rather is in hk, it opens vertically, it becomes x minus h squared plus 4a times y minus k. Additionally, in our standard forms, if a is greater than 0 and it opens horizontally, it means the parabola opens specifically to the right. If a is less than 0, then specifically the parabola opens to the left. For vertically oriented parabolas, if a is greater than 0, then the parabola opens upward. And if a is less than 0, the parabola opens downward. Now, let's go to the different parts of the parabola that is usually requested of us to look for. First and foremost, the most obvious of the parts of the parabola that we have based on its equation in standard form would be your vertex, which is either in 0, 0 or either in hk, depending on the equation that you have. After figuring out the vertex, the next thing that we can do is figure out what is the value of a from 4a. So whatever the value of 4a is, divided by 4, so you need to get the value of a. Because the value of a and where the squared term is, the squared variable is, tells you whether it opens upwards, downwards, or opens to the right, opens to the left. You have to figure that out. Then from there, once we get the value of a, we can also get the coordinates of the focus. Because the focus is just a distance, literally the value of a distance from the vertex. So as you can see here, from vertex to this, that's a units. So let's fix it here. Let's write it. The value of A tells us where the focus would be. Also, on the opposite side, A units would be where your directrix would be. Say, for example, if your focus is at A0, then the directrix will be x is equal to negative 8. If your focus is somewhere else, then you go A units from the vertex, and that's where your directrix would be also. If it's the other way around, let's say your focus is at negative A0, then the directrix becomes x is equal to 8. So it depends on the orientation and where your vertex would be. Now, apart from the focus and the directrix, we also have a special line segment here. As you can see, we have this line segment that is parallel to the directrix, and it passes through the focus, in which its endpoints are on the parabola. We call this line segment latus rectum, or sometimes the focal width, or sometimes the focal diameter. But in where we are, we usually use the term latus rectum. So, the specific part that we usually use, and it's also useful for graphing, are these 2 points that are the endpoints of this line segment. So, we usually call them the endpoints of the latus rectum, or ELRs. As you might have noticed, their x value is 8. So, if we have, for example, y squared is equal to 4ax, for this specific points on the parabola, x is equal to a. With that in mind, y squared will be equal to 4a times a. This becomes y squared is equal to 4a squared. Getting the square root, y will then be equal to positive and negative 2a. This tells us that we have here the coordinates of this point with abscissa a, and then since y is equal to 2a, this is 2a. Here, the abscissa is a, but negative this time, that's negative 2a. Which tells us that this is actually 2a, and this distance would also be 2a. So, the endpoints of the latus rectum in this specific case will have the coordinates a and 2a, and then a and negative 2a. Sometimes it will be a positive negative 2a. Again, depending on the orientation. Now, apart from these parts, there are also other parts that are sometimes asked of us. For example, we would have to find the length of this line segment, the length of the latus rectum. The length of the latus rectum is given that since this distance is 2a and the one below is also 2a, the length of the latus rectum is 4a. Apart from that, we also sometimes look into the equation of the latus rectum. Apart from the equation of the directrix, we also look into the equation of the latus rectum. And take note that the directrix and the latus rectum are parallel, which would mean that if the directrix is x equals something, a vertical line, then the latus rectum is also x equals something, another vertical line, and vice versa. If the directrix is y equals something, a horizontal line, then the latus rectum is also y equals something, another horizontal line, which depends on the position. And then finally, we also sometimes look into this line segment that I just drew, the one that passes through the vertex and the focus. And this is what we call the axis, or sometimes the axis of symmetry. Sometimes we shorten it as AS. Now, so the axis of symmetry is the one perpendicular to the directrix and the focus, which would sometimes, which the equation would sometimes give us a hint to the directrix. So in this specific case, the directrix here, since it passes through A, then the equation is x is equal to A for the specific drawing. And for the axis of symmetry, the equation is, since it passes through 0, 0, y is equal to 0. As you might have heard, I always say it depends because we had four equations for the standard form. And even though we can use this to analyze, if you prefer formulas, here are the set of formulas. For the first one, if the vertex is at 0, 0, we have the case where it opens horizontally. Here you go. This side. And if it opens vertically, this side. Then we also have if the vertex is at HK. This one, if it opens horizontally, and this down below is the one if it opens vertically.